Well, the great thing about the IH2 process is it converts biomass directly into gasoline and diesel blending components. So it's really unique in that way. No other process that I know of can actually do that type of conversion.
Most experts will agree that we're headed towards a number of problems with regard to both feeding the world's population as well as fueling it, meeting the energy demands. This is because the world's population is expected to increase by several billion people in the next 30 years, and the number of cars and the requirement for global commerce, transportation fuels is set to go at least a factor of 2 higher. These both potentially can compete for agricultural land. Here's the problem. We need to find a way to take agricultural land and do dual purpose. Not only grow food for the world's populations, but to use the leftover bits to manufacture renewable transportation fuels.
Our partners in this project include the U.S. government, or the Department of Energy. We also have a lot of different feedstock partners. People from the forest products industry, people from the agricultural industry, and people with specialty feedstocks.
One of the underutilized resources that will be available now as well as in the future, and perhaps become more important in the future, is solid waste, municipal solid waste, garbage in particular. If you think of all of the requirements for food and for energy, as we grow more and more food, we're going to have more and more residual biomass, as well as more and more consumer goods. If you look at that as a resource, a technology that can cost-effectively convert municipal solid wastes into renewable energy will be a very important technology to have.
We found that any feedstock with a suitable amount of hydrogen, carbon, and oxygen can be used in the IH2 process. The IH2 process has been tested with wood, corn stover, bagasse, macroalgae, microalgae, and municipal solid wastes.
Our benchmark for renewable fuels production is primarily economic, and the barrier represents the cost of fossil fuels as an alternative. As important as it is, people aren't going to be able to, or in many cases willing to, provide a premium in terms of cost, so that the benchmark has to be geared at fossil fuel prices or below.
The IH2 process makes fungible hydrocarbons economically and directly from biomass. It has a relatively low capital cost compared to other competing technologies, and I want to emphasize that it's practical. We can demonstrate this process, we can run our pilot plant 24 hours a day, and we don't need any really exotic components or systems or materials in order to make it work.
Continuous operation of the pilot plant validates the product quality that we found from the lab testing, and it's important throughout upscaling to pilot plants and commercialization.
You can put this anywhere there's a road and access to resources, because it is a self-sufficient system. All the inputs we require are the biomass feedstock and the catalyst that's used, and with that we produce finished products.
The IH2 process also can potentially be implemented in an integrated way, so that this will basically be a big box into which you push biomass at one end and from which you recover hydrocarbons at the other end.
Several of the advantages of the IH2 technology are speed to market, its simplicity, its cost effectiveness, and the fact that it produces, in the end, a hydrocarbon as opposed to, let's say, oxygenated fuels.
What the IH2 process does very effectively is it breaks down the biomass into smaller molecular fragments which are oxygenated, and it then removes the oxygen from the structure of those molecules very efficiently and very rapidly. It adds hydrogen to those molecules in order to render a finished hydrocarbon product that's going to be in an appropriate boiling point range for gasoline or diesel fuel applications.
The production cost that we're able to achieve with this system is about $2 per gallon or less, which is very efficient. And we're going to see a 25 to 35% increase in the global appetite for energy over the next 20 years. What we're trying to do is come up with alternatives that help supplement our supply. And those alternatives can be deployed in rural economies, not only in North America, but all the way around the world.